Good day, viewer. Here I'm demonstrating a multi-threaded project in which our task was to speed up certain processes via multi-threading. I have two examples to show today. As the first example, I couldn't really figure out why it wasn't working at first, so I swapped to a different part of my code to try to optimize with multi-threading, and that didn't work for a while either. But when I figured out the second solution, I then figured out the problem with the first solution, which was running in debug. Debug usually runs worse, so I thought it'd be a perfect environment to test multi-threading, but the threading doesn't really work in debug, at least not with the settings I have. Maybe there's something I can take off to let the threads run wild in debug, but for now, it still shows a considerable speed up in release mode. So my two examples here luckily show different kinds of threading. One has threads kind of start up, do a thing, and then terminate. And that's just kind of like loading up some data at the start of the program. And then I have some thread pooling for my physics side of things here. So I'll jump in with the physics side here. This is a function to test if a sphere intersects with a triangle in a mesh. And it's pretty intensive. I have it set up so it will always detect when along a sphere's path it hits an object, and it calculates its balance, and if it bounces off two things in one frame, it detects that as well. So it is pretty simple, just sphere, triangle, but it's still intensive enough. But I'm not going to get into the actual physics side. All you need to know is that with my AABB setup, I have it grab a bunch of triangles, and I have my AABB setup. So it's very unoptimal. It should just be one box. There should be no recursion. So I set up so it has to check every triangle in this. I think it's about an 8,000 triangle flat plane mesh per frame. So just to really push it as much as possible, because it's hard to get the frames down in release mode. Now this is my not threading side. This is where I do the threading. So I have a bunch of threads going, just kind of like spinning with sleep 0 because they don't have any work. And then here I divvy up the workload of the triangles, and I give them to the threads. So I give each of the thread, I can go to my thread structure, which I give to them. I give them the shape that we're currently working on. So the sphere in this case, I give them a pointer to the full array of triangles, and I give them the array size. So I give them kind of just like an index of the array, and they go a certain amount. So I just kind of cut up the array like that. I give them my main physics class just so they can call functions for it. And then I set bool to has work, and these are just internal variables. This is for testing. I can get rid of that, but I give that to them, and then I just I iterate through all the threads, and then I just loop sleep 0 while that thread has work. So I'll eventually go through all the threads and confirm they don't have any work, and then I do a check for a variable that shows the soonest collision and the hit normal for that. So I can quickly show off what the thread's doing up here. Here's the thread. So when it starts up, it obviously gets the thread. It casts the void pointer to the thread info, creates some variables it'll be using, and then I just have an infinite loop here. It cannot escape unless I terminate the whole program. So here's where it goes when it doesn't have any work, and once it has work, it exits here and it goes back up here. And it loops through the triangle array that it's given, and it calls this test moving sphere triangle function, which will return the soonest time that the sphere hits a triangle and the hit normal. And then very simply, it maintains kind of through this whole thing it has to check, it maintains like the soonest hit. And then if it's less than or equal to 1.0, which is the end of the update frame, it goes to this update collision function in the physics class, which has a critical section. Of course, they loop here if someone's in it, and if not, they go in and they see if it's this value is sooner than the one stored in here, and if it is, it updates it and leaves a critical section. So I can run that real quick right now in release, of course, because threads don't work in debug. I'm just glad I got it working, at least. Sometimes you keep beating your head against something and you just have no thread to follow for solving it, and it's a little, it turns you into a little bit of a psycho. But I'm recovering. I've recovered. Anyways, so here we have our sphere here. I don't have the physics on, so the FPS is pretty good. I'm going to So there. Now it's touching. It's the the plane. It's checking every single triangle in this plane. It's a very unoptimized plane, so yeah, it does have like 8,000 triangles. You can see the FPS is around 800, goes down to 600 occasionally. Now, with the press of a button, I can enable threading, and it jumps up to mostly stable 1200, with a very rare occasional dip down to the 800s. Whatever. But that's example 1. Let me jump to example 2, where I load my AABBs. So let me change this here. So yeah, this is my min try count. So like the leaves of the AABB tree can at most have, or sorry, the oct tree can at most have 9,000. I'll put that back down to 25, which is a bit more reasonable. Gives us something to chew on while it builds. Let me change this back here as well. Oops. Just to show off the power of it, I have it load a bunch of duplicate models, which are my biggest models. The train, they have like 130,000 triangles each, so just, especially in release, it shows the difference in power there. So this is the old unoptimized version. We can run that one first. And I do output how much time it takes. Generating AVBs. And it took 2.6 seconds. It's pretty fast, but it could be faster. So set this to false, and it will go down here, and it'll just generate a bunch of space on the heap for all the thread info. So I generate a thread per model as well. So I generate thread info, handles, IDs, and then I generate all the new AABBs we'll need for each model. And then in here, I set all the thread info at the index, cast to a void pointer, and then I start up the thread. And I loop through all that, so there's a thread out there for each of the models that have been requested that we make an AABB out of. And then after that, while they're working, I can do a little bit of work, and I can just put all these AABBs that I generated up here into a map. They're just the pointers, so there's no real issue there. Then I wait for all the objects here, delete all the info I don't need anymore on the heap, and then I output how much time it took. So if you recall, I think it was like 2.6 seconds for the old version. And I'm going to run this here. And boom, 0.4 seconds. Definitely a lot faster. And if I had, hundreds of models, I'm sure this would be even better. Which I guess I could do, but I'm not going to start doing that. But yeah, that's everything for this video. Thanks for watching.